everyone, I'm Tim Kington and this is Coding is for the Birds. In this sequence, we're working through the advent of code problems from 2021, and we're on day 3. Here's our problem for day 3. Go ahead and pause the video and read the description. This one's a little bit harder than the first two were. We're going to be given a list of binary numbers, and then we need to calculate these two numbers called the gamma rate and the epsilon rate. To do that, we need to take our input and we need to look at each position in this binary number. So for the first digit, we need to figure out what's more common, a 1 or a 0. In this case, 1s are more common. And then we do that for each column. So the gamma rate is going to be a number with the most common bits in each position. So for this input, it should be 10110. And then the epsilon rate is using the least common bits from each position. Then we need to multiply these two numbers together, and that's the power consumption of our submarine. I've got my puzzle input and a little program here that will just read the lines in and print them out. And I'm thinking this might be hard enough that we need to use the sample input to debug our code. We'll see. There are a couple of ways we could tackle this. One is to deal with this purely as strings, and the other is to actually use bit manipulation. Now my input strings look like they're, I don't know, less than 16 bits. So we could certainly do this with integers or even shorts, it looks like. But I'm not sure if it's going to be easier to use bit manipulation or if we want to just use string operations here. Well, let's try bit manipulation. That'll probably be more interesting. So we have our lines being read in. I think it's going to be useful to keep these around in a list. So let's go ahead and create a list that holds our input. And it looks like VS Code doesn't import that list automatically for me. So here we'll put the line into our input list. Now we've got our data, and we're going to need to calculate our gamma, whatever they call it, gamma rating. So this is going to use each bit in our input. I think what we want to do is go through the lines and look at the first character, and I guess we'll just check for 1s or 0s here as characters. So we'll say I'm going to say position is 0, while position is less than the length of our line. So I guess we'll make that a variable. Line is input 0.length. All of our bit strings ought to be the same length. So we're going to iterate across the bits. So for position equals 0 to the length of our line, pause plus plus. So we're going to start by going down the first column. We'll say for each line, we'll get the character at position. So C equals line.char at pause. And then we're going to count it if it's a 1. So we'll say if C is 1, num1s plus plus, and we're going to have to count this for each position. So we'll say num1 0 here. And then down here, we're going to turn the bit on if num1s is greater than half of our input length. And when we turn it on, what that means is we're going to left shift our gamma, and then we're going to OR in the new bit. So here we'll say gamma left shift equals 1. I think we can do that. And then we'll say OR in the bit. So the bit is going to be num1s is greater than input length over 2, right? So input dot size over 2. So if more than half of the bits were 1s, then our bit is a 1, otherwise it's a 0. And I guess we can make this more readable. We'll say gamma equals gamma left shifted 1 ORed with bit. And let's print gamma here. And I think maybe I'm going to try this for the sample input first. Let's do that. So I'm going to go over here and replace this with the sample from the problem description. And we'll run this and we'll see what happens. So I got a number 22. What I really need to do here, I guess, is convert this to binary so we can see if it's correct. So I think I can say string.value of, or I can say integer.toString, yeah, to binary string. Okay, so we got 10110. And in the problem description, that is what we're supposed to get. Epsilon is supposed to be the inverse of gamma. So I think we can just say not gamma here. This will give us all of the bits inverted. So let's go ahead and print that out. Space and then to binary string epsilon. And so we ought to get 01001. Well, we sort of did. So here we will do this. Well, that was interesting. The power went out here. That came out kind of cool in the video, so I think I'll just leave it in there. All right, the problem that we were trying to deal with was inverting gamma. Gave us the right thing here at the end of our number, but we also got a bunch of leading ones. We could try to create a mask to mask off the right bits here. I think we can get a mask correct if we say, okay, so we want not gamma, and then we're going to AND it with a mask. And the idea of the mask is it's going to be zeros everywhere that we don't care about the bits. And it'll be ones where we do. So I think if we take not 0, which is all ones, we left shift it, the number of bits we care about, which is the line len. And then we invert that. This is kind of nasty. That might do what we want. Otherwise, we're going to have to resort to the debugger. There we go. We got it. Okay. So I think this is the right result. Now, we printed out our 2 bit fields, and then let's print out the product of epsilon and gamma, which is what our puzzle answer actually is. And it's going to be, what, 198. Which is what we should have gotten. So now we can go back to the real input for the puzzle and run it again. Get rid of that. Oh, I guess there's going to be a trailing line because that's what the editor's doing when I save it. So maybe 741950 is going to be the right answer. All right. So how does this work? We read the lines in, we start with gamma at 0, and then I'm looping through the position. So first we're going to consider the first column of each number, then the second, then the third. We're going to count the number of ones that appear in that column. So for each input line, we get the character at that position, and if it's a 1, we count it. Then we figure out if the most common bit is a 1 or a 0. So if the number of ones is greater than half of our length, half of the number of numbers we were given, then it is more common. 1 is more common, so we'll use 1. Otherwise, we use 0. And then we're going to add that on to the end of the number we're building. So gamma originally is 0. Then we're going to left shift it a bit, which doesn't really affect it. And then we put something into that lowest bit. So if I write this, I might write it as 5 zeros. When we left shift it, it's still 5 zeros, but then we're going to OR it with our bit. And in the first case, that's going to be a 1 because 1 was more common. So when we OR it with a 1, we now have a 1 in the last position. The next time around, we're going to left shift it 1. That's what this is doing. So that 1 moves a position to the left, and then we're going to OR it with our newest bit, which will possibly change this last bit. So each time we are shifting what we've got to the left to make room for a new bit, and then we're ORing the bit that we just calculated into that last position. So gamma is being built from right to left. Well, I guess it's from left to right. We're shifting it left, and we're adding digits onto the end as we go. And when we get to the end, we'll have all of the bits that are the most common bits. Then we had to create this mask to get epsilon right. So I took not 0, which is a bunch of 1s. So let's say line len is 5, and we'll only worry about 8 bits here. So not 0 would be 8 1s. This left shifted line length would be moved to the left 5 positions, and we're going to shift zeros in from the right. So it's going to look like this. Then we have another not here. That's going to invert this again. So now it becomes 0, 0, 0, 1, 1, 1, 1, 1. And then we're going to take not gamma and AND it with this. So not gamma, if you remember, came out as something like a whole bunch of 1s and then 0, 1. I forget what it was. I think it's 0, 1, 0, 0, 1. So it looked like this. If we take this and we AND it with this number, which also has a bunch more zeros on the front, what's going to happen is only these last 5 digits will be kept because we have 1s here and everything else is going to get killed by these zeros. So the zeros will wipe out all these 1s, and then the last 5 1s will match up with these bits, so we will keep these bits, and we wind up with the epsilon that we were looking for. All right, let's take a look at part 2. Now we need to calculate an oxygen generator rating and a CO2 scrubber rating. And so what we're going to do is first we'll consider the first bit of the numbers. And if we're dealing with the oxygen generator rating, we want to determine the most common value. So we're going to go through our input list, find the most common bit, just like we did before. And for the CO2 scrubber rating, we'll find the least common bit. And then we're going to filter our list based on that. So once we find the most common value for the first bit, we'll then filter the list and keep only the numbers that have the right value in that first bit position. Then we do it again. So we look at the next bit, but now we're only counting the numbers that were kept. So if we threw out some of the numbers, those don't affect our counting which bit is most common in the second position. They're already gone. So we're going to count the most common value in the second position out of the values that still remain. And then we're going to eliminate more values. And we keep doing this until we get down to a single string. Okay. So do we want to do this separately for the two? Let's go ahead and do it for the oxygen and then figure out what to do about the CO2. So we have our input list and we read our data into it. We're going to loop over pause. We're going to count the 1s. And this said something about a tie too. What did it say about the tie? Where is it? It's up here. If 0 and 1 are equally common, then we consider 1s to be more common and 0s to be less common. So anytime they're equally common, it's a 1. So we need to check that. So if the num1s is greater than or equal to half of the bits, then we'll consider it a 1. Okay, so we're going through, we figure out the more common bit, Now we need to filter out all of the strings that don't match that bit. I guess we don't really need gamma anymore. We might as well still calculate it. It doesn't hurt anything. Now we're going to go through and filter everything that doesn't have the right bit in it. So let's say list of string next. Create an array list. We're going to iterate through. Actually, we can. We don't really need a second list. We can do this with an iterator. So we'll get an iterator while iter.hasNext. And then we're going to check the string. So we'll say, we know what the bit value we're looking for is. And then we can get the character at this position. We'll just say line bit equals, yeah, we need to get the line. So string line equals iter.next. Line bit is line.char at pause is equal to 1. So this will be a true false value. I guess we could get rid of gamma and make this Boolean, and then these will be comparable. Sure, let's do that. So our bit here is now going to be Boolean. We'll comment out the gamma calculation. So our line bit is true if the line is a 1. And then we're going to keep the string if line bit and bit are equal. So if line bit is not equal to bit, iter.remove. So that'll throw the string away. Now we're going to do this until we have one string left. So now at the end, if input.size is equal to 1, break. And then at the end, we're not doing this stuff anymore. I guess we'll just print it out. So let's print input.get0. Let's see what this does. We got 11110. What are we supposed to get for this test input? 10111. So that didn't work, right? All right, let's take a look at this in the debugger and see how it does compared to what we're expecting to happen. So after our first pass, bit is true, and we have 7 things left in our array list, and they are the values that started with a 1. So that part looks pretty good. The second time through, bit was true. I don't think that's right. When we consider the second bit, there are 4 0 bits and only 3 1s. So we should have gone with 0. So what happened here? We counted our 1s. The number of 1s was 3, so that part was right. The thing that's wrong is we weren't dealing with odd numbers here, and this rounding is causing an issue. So I guess one thing we could do is num zeros is input.size minus num ones. And then here we'll say bit is num1s is greater than or equal to num0s. That's a nicer way to do this anyway. I guess I'm going to go ahead and get rid of this gamma code. I don't like having commented code hanging around. All right, so this is easier to read now too, right? It's pretty clear what we're doing. I think that probably fixes our issue. 10111. I think that's what we're supposed to end up with. It is. So now we have to figure out how to do this for epsilon. We want to use the opposite of bit. Do we just want to have 2 lists? I guess we could do that. I can move this into a function or something. Let's just have 2 lists. we'll say oxygen equals input. No, we need to make a copy if we're going to use the iterator approach. New array list of input, and then list of string CO2 equals a new. Actually, this can just equal input. It's fine if we change it for one of them. That line len is okay. This part's okay. Here we're going to go through and count. Oh yeah, this doesn't work, does it? No, we're not going to do it this way. The whole part needs to be repeated for both, right? It needs to be I guess we could make this whole thing a function. That's fine, let's do that. So we'll say filter list, and we'll pass it input, and we're going to tell it whether we're looking for ones or zeros. So this, whether we're looking for matches with gamma. So we'll say true. And this is going to, I guess, just print its result. We don't even need to do anything special there. And that's it for me. And then we'll have our function. So static void filter list takes a list of string we're calling input and a boolean matches gamma, or matches bit really is what this should be called. And so we'll be past our input. We're going to go through and count the ones. We'll choose whichever one is more common. We're going to go through and do this iteration. And then if this is the opposite of matches bit, we want to remove the value. So I guess if line bit is not equal to bit is not equal to matches bit. Not very easy to read, but that should be correct, I think. We're going to remove it. When we get down to one we break, we print out our result. At the end, we're going to close our, whoops. What happened there? At the end, we're going to close our scanner. And then I think here, if we say filter list, I guess we can't really use input over because input's been destroyed, right? So this will actually be a new array list of string input. And then this time we'll destroy input. Let's see what this is going to do. 01010 and 10111. 10111, 01010. Looks like we got it backward, but otherwise correct. So I guess this needs to be equals matches bit. Yeah, it's actually, the way to read it is like this. Line bit is equal to bit is not equal to whether it should match. Yeah, I think that's really how we should have written it. Okay, so now we're getting them in the order we expected, which doesn't really matter much. Okay, we do need to return our result here. So this is going to return, I guess, an int. So here we need to convert our binary string into a number. So we're going to return integer %, input.getZero. And then I thought we could pass a radix here. Yeah, I think that'll work. So there's your base. Okay, so this should be what? This is 7 and 1623, and this is 10. So we can see if those are right, I guess. Ox is this. CO2 is this. And then we'll print out oxygen, CO2, oxygen times CO2. 2310, 230. So that's the right answer for the example, I believe. Yes. So now let's put the real puzzle input back in here and see what the answer is. All right, we're getting 903,810. And that's it. All right. I'm reasonably happy with how this turned out. The things I could do better, maybe. I'm kind of tempted to try to redo this in a more functional way where whether we're looking for the more or less common bit is sort of passed in as a function or something. But this isn't terrible code. We're going through each position, counting the more common digit, and then we're filtering appropriately. If we're down to one line, we break. This really isn't so bad. I just feel like maybe there's a nicer, slightly more functional way to do this. This passing in false and true here is a little bit ugly. I'd rather pass in like a filter function or something like that. But this comes out with the right answer and isn't particularly nasty. Well, I said last time that the problems get more interesting as we get further into the month, and we already had to do some bit masking. And the refactoring for the second part of this problem was pretty interesting too. We'll come back next time and see what day 4 has in store for us. I like these problems a lot. They're big enough to be challenging, but you can still get them done in a reasonable amount of time. Thanks for watching. Don't forget to like and subscribe.